In this video, we're going to start off by defining something called a Saccheri quadrilateral. And it goes like this. Given line segment AB, that is going to be the base of our quadrilateral, AB. Let C and D be 2 points on the same side, so they either go above or below. Either way is fine. I'll go above. And the line AB, let's see, AD has to be orthogonal or perpendicular to AB. So the point D has to be right above A, like that. So we have a right angle there. And what else do we have? BC has to be perpendicular to AB as well. And these two sides, these two line segments have to be the same length. So we have to put C right above B, similar to what we did before. And these two line segments have to be the same length. So we have a right angle there as well. So the only thing not specified is this top part here. And it's not going to be a line segment. This could be any number of things, but it could be like an arc of a circle. Something like this. Yeah, that's good. So let's mark, what we have. We have these two angles are right angles, and we have this length is equal to that length. That is a Saccheri quadrilateral. We'll talk more about about this in a few minutes. Now, the base is that, obviously. The base angles are these two right angles. I don't even need to put an arrow to those. The legs are these two sides, this one and this one. The summit is what you would expect, probably. The summit is that top side. And then the summit angles are these right here. And you can notice that in this case, these angles are less than 90 degrees in a Saccheri quadrilateral. And we're not using Euclidean geometry yet. But here's a note. In Euclidean geometry, a Saccheri quadrilateral is just what I'm going to call a normal quadrilateral. Or sorry, normal rectangle. So we can't have this situation where it looks curved when we are in Euclidean geometry, which we will be discussing soon. Okay, now let's take a look at a more specific example of a Saccheri quadrilateral. We'll call it ABCD in Poincaré's model, which is non-Euclidean geometry. And I'm going to make one more comment about it. Space is a disk. Okay, so it's not a whole XY plane. It's just, you see this dark circle? The inside region of that circle gives us a disk. Okay, so here's what we have in this model. We have the disk, and then notice we have, let's talk about this line first. This right here is like, you could think of it as the equator. It goes from east to west. It's a diameter of the circle. Okay, so that is a line in this geometry. If it goes from, if it's a diameter. Now, how do you get other lines? Other lines turn out to be from other circles that intersect this circle at right angles. That's a right angle. If you get really close in there, that's a right angle. That's a right angle. That's a right angle. All of these are right angles. When you do intersect that, these turn out to be lines. If inside the disk, this whole thing right here is considered a line. This whole thing here is considered a line. This is also a line. Maybe I should have called them line segments. Okay, so if you notice, we have a four-sided figure in here. Here's the base from there to there. That's a segment. We're not going to continue on. Here is a segment. Here is a segment. And here is a segment. So that's just an example of one quadrilateral, a Saccheri quadrilateral, where space is a disk. And again, we call this Poincaré's model, non-Euclidean geometry. So notice what we have. What can be said about the summit angles? These are the summit angles. And it's pretty much similar to what we had up here. And it's obvious that they are less than 90 degrees. Less than 90 degrees. And what does that mean about the four internal angles? Well, if you add them up, it's not going to be 360 degrees. I don't know exactly what it's going to be in this particular specific Saccheri quadrilateral. Up here, I know it's going to be less than 360 because we have two right angles and two angles that are less than 90 degrees each. But here's a nice example of a Saccheri quadrilateral in Poincaré's model where space is this disk.